Hello and welcome to Math Class with Mr. Head. Today we're going to learn two different strategies for multiplying decimals. Multiplying decimals is very similar to multiplying whole numbers. That's the first thing I want you to understand about multiplying decimals, is it's pretty much the same. There's just one additional step. Let me show you with these example problems that I have here. Our first one is 12 times 8. 12 times 8 equals 96. Now, 1 and 2 tenths times 8. 1 and 2 tenths times 8. That is actually equal to 9 and 6 tenths. And then 1 and 2 tenths times 8 tenths is equal to 96 hundredths. What do you guys notice about these three examples? Did you guys notice that they all have the same digits in the same order? And that the only difference is the placement of the decimal point? So when we're multiplying decimals, we multiply a number in the same way that we did when we were multiplying it as a whole number. The only difference is that we then have to decide where to place the decimal point in our answer. So let's take a look at the strategy of estimating to place our decimal point. The first strategy is using estimation. So 6 and 8 tenths times 2 and 1 tenths. I will estimate that to be 7 times 2, which is equal to 14. After I've written down my estimate, I want to go ahead and multiply these two numbers as if they were whole numbers. So 68 times 21. 1 times 8 is 8. 1 times 6 is 6. 2 times 8 is 16. 2 times 6 is 12. Plus 1 is 13. Sorry, that's an ugly 13. Let me correct that. Erase that and rewrite it. There we go. That's better. All right. Then we're going to add these two partial products. 8, 12, 4, 1. So 1, 4, if our answer was a whole number, it would be 1,428. However, we know that this is a decimal. So we need to see where to place the decimal. If we looked at our estimate was 14. That means that our answer should be pretty close to 14. That helps us know exactly where to put the decimal right after the 4, before the 2. So I'll go ahead and write out my answer here. 14 and 28 hundredths. 6 and 8 tenths times 2 and 1 tenths is 14 and 28 hundredths. When we're multiplying using the estimation strategy for multiplying decimals, we multiply the decimal as if it was a whole number, and then we use an estimate to place the decimal point. That's our first strategy. Now let's look at strategy number 2. Sometimes estimation is not as helpful or as practical as it is in the earlier example. Take this example, for instance. 72 thousandths times 2 hundredths. If we were to round both of these numbers off to the nearest whole number, we would end up with 2 zeros, and that doesn't really help us solve this problem or place the decimal point. So another strategy would be to use our understanding of powers of 10. So when we're multiplying decimals by using the strategy of powers of 10, we'll multiply the decimals once again just like they were whole numbers. But then to place the decimal, we're going to count the digits to the right of the decimal in both factors to place the decimal. Let me demonstrate it for you. So I'm going to go ahead and write out these two factors here. 72 thousandths times 2 hundredths. Some of you might be thinking, Mr. Head, you didn't line up the decimal points. Remember, right now we're multiplying this as if they were whole numbers. When we're multiplying decimals, you do not have to line up the place values. You do not have to line up the decimals. In addition and subtraction of decimals, it's very important to line up the place values. But that's one thing about multiplying decimals. You do not have to line up the decimal point. So let's multiply it just like it was a whole number. 2 times 2 is 4. 2 times 7 is 14. So if this was a whole number, our answer would be 144. However, we know this is a decimal. So let's use our understanding of powers of 10. In our first factor, we see that we have 1, 2, 3 digits to the right of the decimal. In our second factor, we'll see that we have 1, 2 digits to the right of the decimal. So if we put both of those together, we have 5. Let me write that better for you guys. If we put both of those together, we have 5 digits to the right of the decimal. That means that we need to move our decimal over 5 places. In a whole number, our decimal would be here. So we're going to move it 1, 2, 3, 4, 5. Just like we did last week with our multiplying decimals by powers of 10, we place a 0 where there is an empty spot. And so our answer would be decimal 00144. Let's look at one more example. Let's use powers of 10 to answer this question. So we're going to start off and we're going to multiply these two numbers just as if they were whole numbers. We're not going to pay attention to the decimal point just yet. We're going to multiply it just like it was a whole number. 5 times 6 is 30. 5 times 2 is 10, plus 3 is 13. 5 times 1 is 5, plus 1 is 6. 7 times 6 is 42. 7 times 2 is 14, plus 4 is 18. 7 times 1 is 7, plus 1 is 8. 2 times 6 is 12. 2 times 2 is 4, plus 1 is 5. 2 times 1 is 2. So let's add up these three partial products. 0, 5, 6, 4, 3. So if our answer, if this was multiplying whole number, it would be 34,650. However, this is a decimal. So let's think about where we need to place the decimal, knowing what we know about powers of 10. Our first factor has 1 digit behind the decimal. Our second factor has 2 digits behind the decimal. Our first one has 1, the second one has 2. If we put those together, we have 3 digits to the right of the decimal. That means that we need to move our decimal over 3 places. Starts off here. 1, 2, 3. So our answer is going to be 34 and 65 hundredths, or you could say 34 and 650 thousandths. So there you have it, guys. That's how you multiply decimals. You do the exact same thing that you did when you were multiplying whole numbers. After you get your answer, you use one of the two strategies then to place your decimal, either estimation or your understanding of powers of 10.